Welcome to The Explainer. Today, we're diving into something really cool, a new trick for training AI. And the best part? It's an idea borrowed from a totally different field, computer vision, and it's being used to make language models smarter, more accurate, and way more robust. Here's the game plan for today. First, we're going to look at the two big worlds of AI training. Then, we'll get into the specifics of this trick from computer vision. After that, we'll see how they managed to fuse it with language, look at the actual results, does it work, talk about why it's so good, and then wrap up by looking at what this all means for the future of LLMs. Okay, let's dive right in. So to really get why this new method is such a game changer, we've got to start with the basics, the two main ways AI learns to understand stuff. The fancy term is representation learning, but all it really means is how an AI builds an internal idea or a concept of something in the world. So, you've got two camps, right? In one corner, you have the big language models. They're what we call generative. They learn by predicting the next word in a sentence, essentially trying to reconstruct the text they've seen. But in the other corner, you have these advanced vision models using a technique called JEPA, and their approach is totally different. They don't try to redraw an image pixel for pixel. Instead, they learn to predict the abstract idea of an object from different angles. And, it turns out that's a much more efficient way to learn. Okay, so what is this powerful trick from the world of computer vision? How does it actually work? All right, it's called a Joint Embedding Predictive Architecture. Yeah, I know, it's a mouthful. Let's just call it JEPA. But trust me, the idea behind it is actually super elegant. What it does is completely shift the goalposts for the AI. Instead of just reconstructing things, it focuses on predicting an abstract idea. It forces the model to go deeper and learn the real essence of what it's looking at. Here's a great way to think about it. Imagine you show an AI a photo of a building at dawn. Now, the old way would be to ask it, hey, can you redraw this picture for me? But with JEPA, you ask something different. You say, hey, predict for me the idea of this building, but at noon. See the difference? You're not asking for the pixels, you're asking for the concept. By comparing its prediction to the real abstract idea of the building at noon, the AI starts to learn what's fundamental about the building itself, not just the shadows or the morning light. It learns the concept, not just the image. Okay, so that's how it works for images, but here's the million-dollar question. How on earth do you apply that to text? I mean, with a building, you have different angles, different lighting. But with words, what even are two different views of the same idea? Well, the big breakthrough, the real aha moment, was realizing you could find pairs of information that are about the exact same thing, just expressed differently. Think about a bug report, written in plain English, describing a problem. And then you have the actual chunk of code that fixes that bug. They look totally different, but they're two sides of the same coin, two views of the same underlying concept. And that right there was the key. Now, what's really clever here is that they didn't just throw out the old way of training. They added to it. So the model is still learning to predict the next word, the standard stuff that makes it good at generating text. But on top of that, they added this new JEPA objective, this abstraction goal. So now the model has two jobs. Job 1, predict the next word. Job 2, predict the abstract concept of the code from the text, and vice versa. It's forced to get better at both. Okay, sounds great on paper, right? But the big question is always the same. Does it actually work? Let's see what happened when they put it to the test. Yeah, the results are, they're pretty striking. We're talking about huge jumps in accuracy. For example, on a code synthesis task, the Llama 3 model shot up from about 51% accuracy all the way to almost 67%. On a math word problem dataset, it went from 56% to over 70%. We're not talking about small incremental gains here. These are serious leaps forward. And just to be clear, this wasn't some one-off fluke. The pattern was consistent pretty much everywhere they looked. The LLM-JEPA method just kept delivering wins across a whole bunch of different tasks. It didn't matter if it was translating plain English into code, solving math problems, or figuring out SQL database queries. The models trained this way just did better, plain and simple. And in some cases, the impact was even more wild. I mean, check this out. For one particular model, OpenELM, the accuracy on a task more than doubled. It jumped by 110%. That really shows you just how much hidden potential can be unlocked when you force a model to think more abstractly.
But it's not just about getting higher scores on benchmarks. The benefits actually go deeper than that. It looks like this new training method also helps fix a really common and frankly super annoying problem with a lot of AI models. And that problem is something called overfitting. It's what happens when a model trains for too long and stops learning general rules and just starts memorizing the answers. Its performance on new stuff actually starts to go down. But here's the cool part. The models trained with LLM-JEPA seem to be resistant to this. Their accuracy just keeps on climbing, even with more training. And that tells us they're learning real, general knowledge, not just cramming for the test. Now, this is a really important point. The researchers wondered, hey, maybe the old next word prediction was already doing this, just as a side effect? So they checked, and the answer was a big, clear no. It turns out just training a model to predict the next word is not enough to get these kinds of abstract reasoning skills. You have to explicitly add the JEPA goal to the training. You have to force the model to think this way. So where does this all leave us? What does this mean for the future of large language models? Okay, so let's wrap this up. The big win is pretty clear. LLM-JEPA is a fantastic way to boost accuracy and make models more robust. But there's always a trade-off, right? And right now, the cost is computation. This method takes about 3 times more horsepower during training, which is, well, it's a lot. The next big challenge is to make this whole process more efficient, to get all these amazing benefits, but hopefully in a single, much faster pass. And that really leaves us with a pretty powerful question to chew on. For so long, we've basically trained AI to be really, really good at memorizing and repeating patterns. But this research points to something different, a way to teach them to understand the world more abstractly, kind of like how we do. So if this is just the beginning, what incredible new things will AI be able to do once we teach it how to truly think and not just mimic? It's an exciting question to think about. That's all for this explainer. Thanks for tuning in.